In this video, we are going to practice some right triangle skills, including sine, cosine, and tangent, and the Pythagorean theorem. And we're going to do that because this lesson, 11.6, includes some skills with right triangles. These skills will be very important as we find the area of a regular polygon. Okay, so for this first problem, I see an angle measure and a side length. And I actually see something similar in numbers 2 and 3, angle measure and a side length and a missing side length. Those are all going to be either sine, cosine, or tangent. This third one has 2 side lengths and 1 missing side length. This will be Pythagorean theorem. So starting with number 1, I'm going to first write the word here at the top, SOHCAHTOA, to help me learn, or to help me decide between sine, cosine, and tangent. Now on this triangle right here, here's the angle I know. Across from that is the opposite side. Across from the right angle is the hypotenuse, and the remaining side must be the adjacent leg. Okay, so opposite and adjacent are being used. Hypotenuse is the one that's just left wide open. There's no number here, there's no variable here. So I'm not using h, which means I'm going to use this part right here, TOA. So we're going to use tangent. Tangent 35 degrees is to 1, as the opposite leg, x, is to the adjacent leg, 10. Okay, so here's a case with this number on bottom where I will cross multiply. So I have x times 1, or just x, equals 10 times tangent 35 degrees. So we have 10 tangent 35, and that is 7.002. So I'll say x is 7.0. Okay, on our next one, I will label opposite, adjacent, and hypotenuse again. So here's my angle. Across from that is the opposite leg. Across from the right angle is the hypotenuse. And next to this angle, but not the hypotenuse, that is the adjacent leg. Now it's adjacent leg that's not in use. Opposite and hypotenuse are. So where do we have opposite and hypotenuse but not adjacent? Right here. So we are using sine. Sine 18 degrees is to 1, as the opposite x is to the hypotenuse 15. And once again, I will cross multiply 1 times x and 15 times sine 18 degrees. So we have 15 sine 18, 4.635, so x is 4.6. Okay, our next one, here's my angle. Once again, I will label the opposite leg across the triangle, the hypotenuse across from the right angle, and the leg next to that angle is adjacent. This time we are not using opposite. Cosine does not use opposite, it uses adjacent and hypotenuse. So we have cosine 28 degrees is to 1, as the adjacent leg, 12, is to the hypotenuse, x. Now this time the variable is on bottom. In these previous two I had a number on bottom, so I cross multiplied. This time the fastest way to solve this is actually just to take these two diagonal from each other and switch them. So now I have x over 1, which is the same as just x, equals 12 over cosine 28 degrees. So now we have 12 divided by cosine 28, 13.59, so 13.6. Okay, now my last one, I don't have an angle measure other than the right angle, but I do have 2 legs and a hypotenuse. One of them is the variable. So we'll use Pythagorean theorem, a squared plus b squared equals c squared. Now don't forget that the hypotenuse has to be c. The legs are a and b in either order. So we'll go with x squared plus 12 squared equals 18 squared. Make sure the hypotenuse is the one over here by itself. So we will subtract 12 squared x squared equals, now we can't just do 18 minus 12 and call it 6 squared. Order of operations would not like that. So we will do 18 squared minus 12 squared, and that is 180. Okay, now 180 is 10 times 8, 18. 18 is 2 times 9, and 10 is 5 times 2, and 9 is 3 times 3. Okay, so I have a pair of 2's and a pair of 3's. Both of those can be taken out of the square root. Now, what square root? Because I didn't write a square root. When I get rid of this squared here, I do that by doing a square root. So x is actually the square root of 180. Okay, so a 2 can come out and a 3 can come out. So x is 2 times 3. And then what's left over at the bottom of the branch is just a 5. So that will stay inside. So x is 6 times the square root of 5.